All right. Hey everyone, welcome to PyTorch Expert Exchange. This is our first series for 2025. And we have with us today Anton, who is a software engineer at Meta. And he's going to be talking to us about how he built the winning solution for the Meta HackerCup AI competition. Just as a reminder, if you're joining live and if you have any questions, please feel free to use the comment section to post your questions there, and we'll try to get to them towards the end of the talk. So with that, I'm going to hand it over to Anton. Please take it away.
Cool. Thanks for the introduction. I'm glad to be here. So, Hacker Cup is a global programming competition hosted by Meta for many years. It challenges people to solve very hard algorithmic problems, and so far it was about humans uh, solving them. And last year was the first time they introduced AI division, parallel AI track, where you don't solve the problems manually, you're very limited in time, you you can only solve them using your AI system. And I took part in that contest out of competition because I'm Meta employee, but still my solution performed very well. And I'm going to tell you how it works. And not just how it works, I will do a bit more. My goal is to make it a little bit practical and show you how you can build this system from scratch without using any fancy coding frameworks, any platforms. You can build it only by writing prompts, and that is possible now with help of the new reasoning LLM models such as OpenAI O1 or the DeepSeek R1 that was released early this week. I'm gonna use this one, and yeah, hope you learn something new. And you can kind of use the same approach, same playbook to build AI agent for any kind of problem you care about. So yeah, let's begin. What is HackerCup? You given a zip file with bunch of problems. Each problem is just 4 files. You have problem statement, just a lead code kind of um, explanation what your algorithm needs to do. Simple sample of input, sample of output, and full input, full data set that your algorithm, your program needs to compute, and you upload the answer. The more problems you solve, the higher you are in the rating, and every round gets harder and harder. This is example of previously I showed you A plus B, just a simple example. This is example of real problem, I think from round 2. This this is, as you can see, we're not going to read it, but it's pretty complex. You need a lot of understanding of the world. There is like a lot of concepts, some stone throwing, energy, distance, some relations. It's pretty hard. All right, why don't we start with something with MVP, the simplest thing possible what we can do? Why don't we just make a script that reads the problem statement, asks LLM to write solution, then we compile it, execute against the uh, full input, and we have an answer. Previously, a system like that would feel like few hours of work maybe. With the assistants like ChatGPT, it can be like 20 minutes back and forth conversation. With LLMs like R1, which I'm going to use, and it's very excited that open source model is for the first time in a while, it's really at the frontier. A model like this is able to build this MVP just with one prompt. I literally took a screenshot of the diagram I showed previously and wrote one sentence. Write Node.js script for my Mac that solves comparative problem using DeepSeek API. If you don't like Node.js, you can use Python, you can use any language, it doesn't matter. One prompt and it just works. It will implement everything. You only need to put your API key token, select the latest model, and that's it. I run it, it wrote the solution, it compiled it, it provided the answer, and with that, you already passed the first round of HackerCup. Just one prompt, and you're already in the game. This is enough for the first round, but let's see how far we can go with this approach. For HackerCup, I used O1 preview model. Back then, it was the state of the art, the best option available, and how well it can perform, how far we can go. We know exactly how far we can go because OpenAI shared benchmark, its Codeforces rating, and it's around 1200 on Codeforces. And if you look at the global distribution of all active competitive programmers, it is green area somewhere in the middle. But the Hacker Cup, every round gets harder and harder until the final round where people like Gennady Korotkevich compete. It has such a high rating that I had to draw it outside of this chart. And people like him compete for everyone wants to win $20,000. So the problems there are so hard that are designed for people like him, and even tourists in the final round couldn't solve all the problems within 4 hours. He only solved 4 out of 6. This just to give you understanding how hard these problems are. And yeah, this here I showed the current state of the art, O3. It has rating 2700. It's like within top 200 people in the world. So today we will try to, I will show you how to improve the system iteratively, step by step. So we push the LLM capabilities to maximum, so it performs much better and solves much harder problems. First step, what we can do after writing the code, why don't before executing full data set, we can use sample input and output to check if it's correct. And also, if something is wrong, the sample answer is wrong, or compilation error, or it takes too long to execute, we can use a kind of feedback loop. Like in ChatGPT, if your answer is not correct, you can ask it to correct and it will fix it. So we can use this kind of loop, and it seems like quite a bit of engineering to implement it, but it turns out we can do it just with one prompt. I copy pasted the previous code and literally asked that below is code that solves competitive programming problem. It works fine, but I need more advanced version. Before computing the answer, validate it. If something goes wrong, send back to LLM. And it works. Just one prompt improves it further. So now you can solve problems from round 2. But here what happens if you go with this solution to round 3. I had this pipeline in round 3 and I couldn't solve anything. No one solved anything except one team, Artigens coders. They solved only one task. And but yeah, and this is how human tracked look like, a lot better. So because it's pilot round of AI division, organizers get us another chance to compete in the final round and to prepare more. And we really need to prepare more, because if we failed to solve anything in round 3, in round 4 the problems will be even harder. So we need to improve the system dramatically. Yep, let's do a couple more iterations. This is what we have now, and let's think how a real person solves the problem. Right now we have one prompt that takes problem statement and outputs the working code, and it's really hard. When human solves algorithmic problem, at first you thinking in some algorithm terms. You come up with some algorithmic solution in some variable form, and then you're going to implement it. So why don't we split it by two steps? At first we write solution algorithmically, and then we implement it to code. This is very easy to implement, just one prompt, we copy paste code, same template, but we asking instead of write verbal description of the solution, include the big O notation, and then implement solution. It works. This is how this reasoning explanation looks like, this intermediate step. And we made the problem a little bit simpler for AI, but now we can actually use this verbal solution more. What if it mentions some building block algorithm like Dijkstra or persistent segment tree? Those are well-known algorithms that a bit hard to replicate quickly, optimally, without bugs. So why don't we read the verbal solution and go to our library if we see some familiar algorithm, and include this algorithm into the code, so it will be easier for LLM. This pattern called RAG, retrieval augmented generation, and you usually do need some embeddings, vector databases, some complex stuff to implement it, but we can do it very easily. I just went to GitHub. There's a lot of libraries with implementations. I copied manually about 200 of such algorithms. I literally created directory in my project algorag data and copy pasted a bunch of these algorithms. And in the first line, I had a comment with title. So my goal is to form a prompt like this with all the options and ask LLM, hey, does solution have anything like that? If so, give me file names. Those file names I will include into the solution prompt, like rug. Sounds a bit complex, but again, just carefully, step by step, you explaining it to the LLM prompt with the same template, and it works just fine. We now have rug, and let's think how can we improve it more. Right now, for every iteration, it's important to use it and kind of do vibe check for several problems to see why it works, why it's not, what are common issues. And one of the common issues is that solution works, it passes tests, it computes answer in time, but then you get wrong answer because it overlooked some corner case. What if graph only have one node or some number is negative? So we can easily cover this kind of corner cases by synthetically adding more tests. And LLM is pretty good at it. Same template, one prompt. There are sample input and output used for validation. Use LLM to manually generate synthetic input and output, generate them in parallel. And it generates us synthetic sample input output now, and our system looks like this now. So as you can see, iteratively, step by step, we went from very small simple MVP to something more sophisticated without writing any code, just prompts. And let's try to think, how good is it now? If you think about this, if you give this system very simple problem like a plus b, it will definitely solve it. But the harder problem is, the higher chance that something will go wrong. Either the code will have bug, or if synthetic tests is not valid, then the whole thing will fail. So for very hard problems, the system still fail most of the time. And this is kind of key insight here. If something fails most of the time, it means it can succeed sometimes. And how we can increase the probability of it? What if it succeeds in 1% of attempts? Why don't we run it 100 times to have probability that it will work at least once properly? We can, yeah. So at this point, I decided let's just scale this thing. The only problem is when you run some C++ unverified C++ code on your laptop, each of these runs can take all of your memory or all of your CPU resources. It's very risky. If you run it 100 times, your laptop will crash for sure. You don't want it to happen during the contest, and the solution is move all this heavy lifting, the C++ execution computing to the cloud. Yeah, I used Google Cloud Run. They have very cool, there are many similar products. It basically allows you to move your container and to spawn as many of them in parallel as you want. Very easy to use. It sounds like it's hard to implement. You're gonna need some microservices, some DevOps, stuff like that. But you can make it possible just with 3 lines prompt. I don't like executing unreviewed C++ code on my machine. I want to move it to Google Cloud Lambda. Please create a separate Google Cloud Run, blah, 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 and teach me how to deploy it. And this one prompt implements this service and gives you all the instructions, and it actually works. Now you can run 100 of those in parallel until some of them succeeds. This is what I did, and now really limitation is not compute anymore, but the LLM inference price. The O1 preview I used was pretty expensive. Within 10 minutes of the contest, I burned over $400, but it's worth it. And good news that DeepSeek R1 is like 30 times cheaper. So these models are getting more cost effective, more smart, more fast over time. This is very exciting. And speaking of progress, just think if HackerCup contest took place 5 years ago, how would the leaderboard look like? No one would solve anything, any single, even simple problem. There was just no technology for it. It seemed impossible back then. Then we got AI Copilot that could continue your line of code. Then we got GPT-4 that could write a function for you. Now with all these test time compute reasoning LLMs, one prompt can make a whole iteration of this system. And within like 5-7 prompts, you can get a system capable of solving world hardest problems that only few hundred people on the world can solve. Yeah, I'm excited to see how it evolves into the future. And yeah, couple more things. Was my solution that I actually used for the competition. I open sourced it. It's basically the same system, but I used front end to orchestrate it because I want to make it more like visual, interactive. But essentially, it's the same thing. You can go to GitHub. You can use it for HackerCup 2025. You can use the prompts, anything you want. And if you want to learn more about agentic workflows, how to build them, what kind of patterns are there, I recommend this article by Anthropic called Building Effective Agents. They show many cool things, very interesting. Yeah, with that, I'm ready for the questions part. Thank you for your attention.
It's awesome. Anton, thanks for the talk. It was really fun to see how you came across like the winning solution. I have a couple of questions, but Mark, I don't know if you want to start. Um, Go for it.
Um, yeah, like let me see. So I'm wondering, like, I mean, when this competition was ongoing, you were using like O1, and I think like since then, like there's been a lot more interesting like reasoning models in open source, and I'm sort of curious if this would have like drastically changed your approach, or if you would have basically picked the same like overall strategy.
Yeah, overall, going forward, I imagine that LLMs will get better and better, and I would, instead of developing my system more, I would simplify it more. I would remove more parts, I'll make it more straightforward, and I will scale it and focus on, yeah, QA and scale this. Yeah, but we will see. Very soon we will have this O3 Mini that's very capable. My prediction is that by the end of the year, the next Hacker Cup will AI actually will overperform humans if there will be someone who wants to pay for inference for it.
It's funny to hear you say this because when we were designing the rules, we were mostly worried about like a very smart human masquerading as an AI. And I think next year like we have the opposite problem, which is insane.
Yeah,
Um,
huge thanks for designing. It was so fun. It's such intense 10 minutes when you have to run it through. You spend weeks preparing and then 10 minutes decide everything. Your heart rate is very high. It's very fun. I recommend everyone give it a try.
and sort of related to this, like I think you mentioned something around how like you would remove more parts. Like, for example, one part for me that feels like the most obvious to remove is the reprompting loop, where you basically tell the model, make this thing faster, or hey, it didn't work. Like this kind of feels like if the model had the ability to run code, you wouldn't have this problem. But because it can't, you basically are in this regime where you're doing this like simple feedback loop. I guess, like, do you have any predictions for which parts of the pipeline you'd want to delete first?
Yeah, the feedback loop was pretty impactful and it was one of the first thing I implemented because it very often it almost gets it, but there is some small thing, and if you use from this is kind of if you rerun it from new starting point where you almost have ready solution and put same amount of reasoning, then it can get. Very often I got working solution after third or fourth retry. Yeah, one more, I think, promising thing for the next time is that with these reasoning models for OpenAI or one preview, we didn't have access to the reasoning chain of thought. It was not available. With open source model, you can see this reasoning in real time, and if you can run multiple threads in parallel, you can analyze these threads in real time and you can detect aha moments or some facts and accumulate them somehow in real time. That can be very powerful.
Yeah, I guess I had a related question. Like right now, you in your approach, you ran all these in parallel and you picked one at random and then just passed that to the final solution, right? So, if going forward, if you had to make that a bit more optimal in terms of like you have 100 solutions, maybe some are better than the other. How do you figure out and optimize the final solution?
Yeah, that was the hardest part. Sometimes you have zero solutions and sometimes you have 20 of them. How would you pick one of them? In the contest setup, I was just in panic. I see the green checkbox, some solution is there, I submit it immediately. But yeah, going forward, I think it's better to have some QA, some more robust, like these synthetic tests to give you stronger signal which one to choose.
Yeah, I guess like in terms of the time that was given, do you feel like 10 minutes was reasonable, or do you think we should have or competition should have had more time or less for the AI track?
I think 10 minutes is reasonable, but it's a little bit risky to spend time for manually uploading results. If we had some sort of API that automatically throws the answer, that would, yeah, make it more, yeah, I would recommend making some API.
Cool. Mark, any other questions from your side?
Yeah, like well, what would you say was kind of like a part that you didn't expect would be like as difficult? Like I think you sort of already alluded to the timing. But like I think if I'm not mistaken, like you weren't an AI person, right, before you engaged on this competition. And so I'm sort of curious like what you found surprising.
Yeah, overall, it's, yeah, was super fun. I have the, so like 15 years ago, I trained my own neural network that capable of solving competitive programming problems. This neural network literally was my own. It's located in my head, and it's kind of, when you know the thought process how to build it yourself manually, it was very fun to extract and try to formalize it in the system and replicate it. Yeah, so yeah, was super fun overall. Uh, a bit, and yeah, yeah, very cool.
So, so a lot of AI people have like a field AGI moment where it's the first time they realize that like machines are better than them at something. For me, I experienced this like both playing chess and like Dota and StarCraft, where AI crushed me. And I guess like was this sort of your first experience realizing like, hey, machines are
Yeah,
could be better than you at something you're very good at?
yeah, definitely better than me. Yeah, it feels. I have mixed feelings about it, but yeah, but it's still not better than the best humans. But let's see how it evolves.
Um, Also, like once since the competition got done, did you try the problems that were given on any of the other models that have come out since? Like just to compare how they did with uh, the solution that you submitted with O1.
Yeah, so I wish I could, yeah, learn more about other approaches. Yeah, I don't know too much, unfortunately, but I think pretty much everyone used the latest, the better model wins. Yeah, uh, cool. Um, that,
Right. Anything else, Mark?
No, that's it for me.
Okay. Looks like there is a question from the live stream. Um, any open chain of thought model from Meta in recent days?
Nothing that I can announce. I think people distill the DeepSeek R1 to, like, in the open source community, to other uh, open models, Llama, Qwen, and other, together with chain of thought, and it performs very well. So there is Llama with chain of thought out there.
Cool. All right. So I think I don't have any more questions. Thanks a lot, Anton, for the talk. And yeah, it was really interesting to see your solution. And congrats on winning the competition. Hope this inspires folks to participate next year as well when we have the AI round of Meta HackerCup.
Yeah,
Cool.
thank you.
Thank
Looking
you.
forward.